All right, we are starting notes 19, if you can believe it. We're on page 248, which is the first page of the notes. And the first page starts out not so mathy. So we're going to fill in the blanks with what I believe, since no one is here to play along with me, what I believe are the most logical answers. But your answers may vary, and that's kind of an interesting idea. And it's actually the idea that we want to talk about. So Mr. Turk opened the blank, got in, put the key in the ignition, and drove away. So I'm going to say car, because I feel like that's how I would answer that. Open the car. But in my experience, a lot of people will have said door, and some people will have said car door, or lock, right? There's a lot of options here. All of them kind of make the sentence make sense, though, and that's interesting. So let's see. Let's carry on. You can never make a blank turn on red because the oncoming traffic will kill you. All right, so if you think about it, you're probably in driver's ed, or maybe you will be, or maybe you were. You can't make a left on red. That's like, that's insanity. There's no way. You make a left, the oncoming cars are just coming right at you. You're gonna hit. So no left turn. I don't think there's a lot of ambiguity on that unless you don't understand how driving works. You can always make a blank turn on red unless a sign is posted prohibiting it. So that's a right on red. So we can always turn right on red. That's in New Jersey, not true in New York State. In New York State, it's the opposite. Like you can't turn unless posted. So keep that in mind. I live like almost right on the border, and comes up sometimes. Well, not for me because I know the rule. All right. Mr. Turk was doing 75 in a 55 zone. The cop saw him and blank. This one, I don't know if there's a right answer. I'm going to say pulled him over. I don't want that to be true, but, you know, what are you going to do? That, yeah, I mean, it should be true. 75 and a 55? It's a huge ticket. Don't do that. Don't speed, everybody. Follow the rules. Give me liberty or blank me death. So this has, I believe, a right answer, but only if you're up on your historical quotes. I'm going to say give. I think off the top of my head, I can't even remember who said that, and that's kind of sad. But I think he was like super, super, super young. But also, I'm not sure about that. So I don't know. I'm struggling on that one today. I've been doing a lot of videos, as you can probably tell from the shirt situation if you've been watching them consecutively, which you probably haven't. So if I hadn't told you that, you wouldn't know. When the cat's away, the blank will play. If you're like a lot of analysis students, you've never heard this expression before. It's a very famous common expression. When the cat's away, the mice will play. They come out, they have nothing to fear. It's like if you have a lot of mice, one of the suggestions is get a cat, right? Because cats will chase them. They're like mostly playing with them, but they play very violently. You know. All right, and then one more. Happy birthday to you. Happy birthday to you. Happy blank. Dear Blanca, Blanca for blank. Happy birthday to you. So I think there's only one right answer here, but you could debate that, right? So this is birthday. Dear Blanca, happy birthday to you. I think that that's the right answer. The issue is there really isn't a right answer to these. There's like, I think, a logical answer, but like we could have been all over the place on this. And you can make a case that you were right, someone else is right, whatever. There's not really a right answer. That's a problem. When we have these sorts of scenarios in math and we want to fill in the blanks, what we want to use is essentially the limit, right? So in math, what we're trying to answer is for a particular x value, that's like your blank. Well, actually, no. For a particular x value, that's like your sentence. What's the logical y value? The logical y value is the blank. We want to fill in the blank with like the most logical answer. So in math, there are definitive answers to these, usually. In languages, it's a little messier. Like you could make an argument one way, make an argument the other way, who knows? In math, not really the case. We're talking about limits, and we're going to do them visually right now. So I'm going to move on to the next page. So we're going to look at some notational things. We're going to find some limits. Most of this is just graphing for the first couple pages. So I think you're going to be all right. Let's see. I'm going to choose a new color. And we need, so in general, you look at the limit as x approaches c of f of x is equal to L. But that's only true if the limit as x approaches c from the left exists and is L, and the limit as x approaches c from the right exists and is L. So that's what we're going to try to figure out here is that scenario happening? And what is the notation, right? So here's our graph. We're going to use that. I'm going to have to like flip back and forth really quickly. I apologize. Might make some of you a little ill. I'm just theorizing that that's happening. I don't actually know. All right. First notational thing. If you look at this whole column, right? Everything has a little negative sign after it. So it's a limit as x approaches 7 from the left of f of x. Limit as x approaches 15 from the left of f of x. So this column right here is all from the left. Ugh, too small. Hold on. Zoom in, zoom out a lot. This whole column is from the left. The next column is all going to be from the right. That's what the little plus sign here means. Okay, so let's find some of those, and then we'll talk more about it. But I feel like for the purposes of your notes, maybe I should make it a little more explicit. So I'll do that here. The limit as x approaches c from the, you always use c, I don't really know why. F of x equals L is pronounced or said the limit as x approaches c, ew, why comma? From, ew, what is happening to my hand? I got it. From the, oh God, the left. This is the longest sentence I've had to write in ages. The limit as x approaches c from the left of f of x is L. Oh my gosh, that was a lot. Over on the other side, I'm going to do it for the limit as x approaches c from the right. So how am I going to do that? I'm going to use little iPad copy and paste magic, and then hopefully copy. Let's see here. Paste, and then let's erase something here from the. Okay, this is going to go, and I'm going to replace it with right. And also, I have to change my notation up here to be. Oh, I don't need to erase anything. I can just change this to a plus. Okay. Whew. So you probably wrote the whole thing in the amount of time it took me to do that. So we got a limit as x approaches c from the left of f of x, limit as x approaches c from the right of f of x. They're both going to be equal to L. If they're both equal to L, then we can say the limit overall exists. Let's do a problem. Limit as x approaches 7 from the left. All right, from the left. What is to the left of 7? 6 is to the left. 5 is to the left. 6.99999 is to the left. So what I'm going to do, I'm going to go on the graph and just kind of trace. So start to the left of 6. So maybe I'll start here and just trace along the graph. And as I get towards 6, I need to answer the question, what y value should I get? Not what y value do I get. What should I get? So imagine yourself, you're on the curve. So let me draw you. This is you. You're on the curve, but you have a blindfold on. How do you blindfold a stick figure? You have a blindfold on, right? And you're gonna walk in this direction, and you're just gonna keep going and putting one foot in front of the other, and you're going and going and going. When you get to x equals 7, where do you expect to put your foot? Not where do you put your foot. You expect to put your foot at, I think this is y equals 8. I think the limit as x approaches 7, the limit as x approaches 7 from the left of f of x is equal to 8. So I'm going to fill that in. So that is the limit as x approaches 7 from the left. Now we're going to do the same thing from the right. So Same idea. You're on the curve. What is to the right of 7, right? To the right of 7 is 8, is 9, is 7.00001 because it's a little bit bigger than 7. So you're on the curve and you're walking blindfolded toward it, right? So here you are, and you got your blindfold on. And the question we're trying, and you're going this way. The question that we're trying to answer is, as you step from 7.00001 to 7, where do you expect to put your foot? Not where do you have to put your foot to stay on the function, just where do you expect to put it? The place you expect to put it, if you are following along, is definitely at 8. It's the exact same place that the person from the left was expecting. So if the person from the left and the person from the right agree on where they should step, we could say that the limit overall with no plus or minus exists and is that value. So the limit overall, and we're only able to do that if these two other columns are the same, is 8. So then you get this other question. The other question is, what is f of 7? F of 7 is the actual value, right? So if you wanted to stay on this curve somehow, as you're walking from the left or the right, if you wanted to stay on the curve, you'd have to actually be up here. And so f of 7 is actually just equal to 12. All right, what I'm gonna do is I'm gonna cut this here because I feel like it might be getting long. And I'm gonna come back and I'm gonna finish all of these. But think about all you've learned. Limit from the left, limit from the right, limit overall. So actually, instead of cutting it there, let me just write the limit as x approaches c of f of x is equal to L, if and only if, which is IFF, which is kind of confusing. If, so if and only if the limit as x approaches c, as x approaches c from the left of f of x is equal to the limit as x approaches c from the right of f of x, and then both of those are equal to L. So saying just this part, saying just this is equivalent to saying both of those. And that's kind of interesting. All right, I'm gonna stop the video here. I'll be back to do more. And this is a big idea. Limits are a big idea. They're gonna stay with you for a very long time. So this is very exciting, and I will see you soon.